Title of my paper is the impact of change granularity in refactoring detection. Mining refactorings in commit history is essential to help developers comprehend code changes and code reviews, and this can provide invaluable information for empirical studies on software evolution. Refactoring detectors detect refactorings by comparing two source code snapshots. Recent detectors use a commit as a chain unit to detect refactorings. For example, in this figure, the code before the commit compared with the code after. Class B is moved from file a.java to b.java. Then the refactoring move class is detected from this commit. However, refactorings that are performed over multiple commits may not be detected. An example of such refactoring found in a repository on GitHub named Ambassador is shown in this page. A refactoring of move class is performed over two commits. The intention of the developer, as expressed by these two commits, is to decompose the source file ambassador.java, which contains two top-level classes, class ambassador and class fast, into multiple source files to ensure that each file contains only one top-level class. In the first commit, the developer copied the implementation of class fast to a new file, fast.java. In the second commit, she or he removed that class from the source file ambassador.java. Overall, she or he moved the class from the ambassador.java to a new source file. We named the refactoring that are performed over multiple commits as coarse-grained refactoring. In contrast, the refactoring performed in a single commit is named as fine-grained refactoring. We wonder, what's the impact of coarse-grained refactoring? In order to solve this question, we investigate features of coarse-grained refactorings by answering three research questions. Research question 1 is to investigate the appearance frequency of coarse-grained refactorings. We found that coarse-grained refactorings are common. They appear in all 19 repositories in our dataset. Research question 2 is to find out which types of refactorings tend to be coarse-grained. We found move-related refactoring types such as move class, move attribute appear most frequently. Research question 3 is to discover why coarse-grained refactorings occur. We categorize the reason into two types as the generation type and the combination type, according to the composition of the coarse-grained refactory. In order to merge code changes in different commits to detect coarse-grained refactorings, we scratch commits using a GitHub repository rewriter tool, git stain, and we name the commits before scratch as fine-grained commits and commits after as coarse-grained commits. The number of fine-grained commits scratched into one coarse-grained one is referred to as coarse granularity. The number of fine-grained commits scratched into one coarse-grained commit is referred to as coarse granularity. Refactoring miner is used to detect refactorings from coarse-grained commits. We compare the refactoring detection results of fine-grained and coarse-grained commits. We regard the refactorings that can only be detected in coarse-grained commits but cannot be detected in fine-grained commits as coarse-grained refactorings. Box plots of the coarse-grained refactoring frequency at different levels of coarse granularity in the 19 repositories is shown in this page. The minimum values of all three box plots are greater than 0, indicating that coarse-grained refactorings were detected in all the repositories at all levels of coarse granularity. We also observed the tendency that frequency increases when coarse granularity increases. We suggest that in the future, refactoring detectors should cover coarse-grained refactorings. In the future work, we plan to extend the current experiment by comparing different refactoring detection tools on a larger dataset.